In this video, which is part 2 of the previous video, we're going to solve systems of linear equations using the addition method, which is the same as elimination. And so let's start with the first example. Just like the previous video, we have two equations and two variables. The two equations represent straight lines, and we would like to solve. And we're essentially looking to see where do these two lines intersect if we were to graph. But we're using the addition method. So the addition method just means that we want to add these two equations and get rid of one of these variables. Get rid of x or y. The first example is already set up for the addition method. Notice that if I were to add these two equations, I will automatically eliminate the y term. And so then we'll be left with an equation that just contains x, and we could solve for x. So let's go ahead and add the two equations. Notice that the like terms line up because we can only add and subtract like terms. (2y minus 2y is 0, so that's gone. We're left with 8x is equal to 40. And then from here, we're going to divide both sides by 8. And so we get that x is equal to 5. We still need to calculate the value of y, and in order to find y, we can go back to the first equation or the second equation and input x. It doesn't matter which equation you choose, you will get the same answer. I'm going to pick the first equation because that one looks a little bit easier for me to use. We're going to subtract 15 from both sides. And we get that y is -2. So you can write your answer as an ordered pair, 5, -2. Again, what this means is that if I were to graph these two equations, then the two lines would intersect at this point. Wherever the two lines intersect, that is your solution. Let's look at the second example. So for the second example, notice that the second equation is not written in the same form as the first equation. Essentially, we want to have x and y on the same side of the equation and then the constant on the other side. You want to make sure that your like terms line up. In this case, the second equation, we need to add 4y, and that way we can have the x's and the y's and the constants line up so it's easier for us to add. So let's go ahead and do that. So add 4y, so it moves to the other side. Okay, now that the like terms line up, we need to add our equations to eliminate x or y. Notice that if I were to just add these two equations, we don't eliminate x or y. Remember, you need to have, in order to eliminate, we need to have the same number but opposite signs. I do not have that situation here. So in order to get a situation where we could actually eliminate one of the variables, we need to multiply one or both equations. It depends on the problem if you multiply one equation or both. You have to multiply by a non-zero constant. So first we want to determine which variable do we want to eliminate. We could eliminate x or we could eliminate y. So you want to ask yourself, is there anything I could multiply the second equation by to make the coefficient 5, we want that to be -10, because if this turns into -10, then I could eliminate x. If we want to eliminate y, we actually will have to multiply both equations, because there's nothing I can multiply 3 by to get -4, and vice versa. It's easier to eliminate x because I only have to multiply one equation. So what I'm going to do is multiply the second equation. I know that if I multiply the second equation by -2, I will get -10x, which is what we want. So that way we can get rid of x. And remember, you do have to multiply every single term. Not just the x term, but every term, because this is an equation. Whatever you do to one term, you have to do to every single term. So now I can add, and when we add, we get 10x minus 10x is 0, and then we subtract our y terms, and that's going to give us -4y, or sorry, -5y rather. -5y is equal to 20. And then from here, we divide, we get that y is equal to -4. And once we get our answer for y, then we're going to go back and we can substitute -4 into the first or the second equation. And I'm going to use the first equation and just substitute -4. So we get 10x plus 3 times -4 is equal to -12, and then multiply. We have to add 12 to both sides. When you add, you get that 10x is equal to 0. And then remember, we need to divide by 10. And when you divide by 10, 0 divided by 10 is 0. And so we have our solution. We have the ordered pair 0, -4. At this ordered pair, these two lines will intersect. Let's take a look at the third example. All right, so this example, the first thing you want to notice is that like terms line up, and we also need to multiply one of the equations to eliminate x or y. So I will multiply the first equation by 3, and let's see what happens. Recopy the second equation. So notice that when you multiply the first equation by 3, what essentially happens is when you add, you happen to eliminate both variables. -3x plus 3x is 0, 15y minus 3y, that's 0. The whole left side is 0. -3 plus 3, that's also 0. This is a true statement. 0 does equal to 0, so this is true. And what this means is that both of these lines are actually the same exact line. And if you have the same line and you graph it twice, they will intersect at all points. There will be an infinite number of solutions. There are a couple of ways to notate that you have an infinite number of solutions. It depends on the book that you're using and what your instructor would like you to do. But one way to write your answer is to just write dependent. So some books are okay with just writing dependent. Another way you could write your answer is to use set builder notation. And so you write your ordered pair such that, and then we pick one of these equations. And this just means that all ordered pairs can be found by using this equation. You can do the same thing, but you can use the second equation. So all xy ordered pairs such that 3x minus 15y is equal to 3. So this is also another way to write your answer. So there are an infinite number of ordered pairs, and we can calculate them using any one of these equations. These are actually the same exact equation. They look different because one of them is multiplied by 3 and the other one isn't, but they are actually the same exact line. And you can actually see that if you take the second equation right here and divide it by -3 every single term, you will get the first equation. Let's look at the last example. Our like terms are lined up, so that's good. We do need to determine which variable to eliminate. In this example, we will have to multiply both equations in order to solve by the addition method. I will choose to eliminate x only because the numbers are smaller. And notice that this is -2 and this is 3. So I need to figure out what I'm going to multiply by. So normally what you would do is just multiply by the opposite number. So this will be multiplied by 3 because that's a 3. And then the second equation will be multiplied by 2. Notice that when you do that, you have to get the same number opposite signs. So this turns into -6. This turns into 6. I know that -6x plus 6x is 0. So we'll eliminate x. You can eliminate y as well. If you want to eliminate y, you would have to multiply the top equation by 4 and the bottom equation by -3. So you can do it that way as well. So let's see what we get. We're going to add, we eliminate 6x. This is going to give us 17y is equal to 34. Divide both sides by 17, y comes out to be 2. From here, I'm going to use the second equation to solve for y, or to solve for x. So use the second equation, substitute 2 for y. Subtract 8 from both sides. And divide by 3. So x is -2. And we can write our ordered pair as -2, 2. And that will be where the two lines intersect.